Go.
Okay class, today we are going to be learning section 3.1, and basically what they want to know is how far it is from the given point to the line, which way the vector is going. So there's a formula that you're going to need to know, and for the distance from here to here, it is d equals s minus t times v sub p, all of the absolute value of that, all over the magnitude of vp. So basically what we're going to do is start plugging in numbers. So s minus t is -1, -3 times the v sub p. And the v sub p is always the opposite reciprocal of the vector. So for like right here, it'll be -1, 2, and all absolute value, all over the magnitude of the v sub p. And so for that, you're going to take -1 squared plus 2 squared, almost square root for the distance formula to find the magnitude. So then you're going to multiply these right here. The x's of -1 times -1 is 1, plus -3 times 2 is -6. It's all in the absolute value. And then you're going to take the -1 squared is 1 plus 2 squared is 4, which is 5, square root of 5. And this is 1 plus -6 is -5, absolute value over square root of 5. And you're not done there because absolute value, they're trying to find distance and you can't have a negative distance. So the distance is 5 over the square root of 5 is your final answer.
Okay, for 7 through 12, you're going to do the same thing, except you are given the slope instead of the vector. But the vector is the same as 1m, which would be your slope, so it would be 1, 2. And you take the opposite reciprocal, which is -2, 1. And then you would just plug it back into that same formula. So you got your s minus t up here, which is -2, 3. Plug that in. And here's your v sub p, all over, all in the absolute value. And then on the denominator, the magnitude of v sub p added together. So what you would get is 4 plus 3 all over the square root of -2 squared plus 1 squared. And it equals 7 over the square root of 5.